Assalamualaikum warahmatullahi wabarakatuh, and good morning everyone. We are from Group 8. So today we will go through the topic predicting customer churn using clustering technique on telco customer data. So let's go. So we have 3 members in our group. First we have Nur Anis Alia binti Muhammad Anwar, our volunteers, and me, Milada binti Omar. And lastly we have Siti Nur Fatihah binti Farhad. So as you can see, we have a lot of that we need to go through for today. So you can see this is our list of content for today. Customer churn, when customer leave a telecom service, leads to revenue loss and increased acquisition costs. Instead of reacting after customer leave, we use classification technique to predict churn in advance. This model uses heuristic data to classify customer as likely to churn or not. In this project, I evaluate 3 popular classification algorithms: SFM, decision tree, and random forest, to find which provide the best predictive accuracy. So here, the 3 algorithms that I selected, which are support vector machine, SVM, a powerful model that find the best hyperplane to separate classes, especially good for high-dimensional data. Second, decision tree, simple interpretable model that split data based on feature values. And lastly, random forest, an assembly method that builds multiple decision trees and average their result to improve accuracy and reduce overfitting. This technique allows us to classify customers as likely to churn or stay based on their features. Now let's dive deeper into the strengths and weaknesses of each algorithm. So first, SVM is a strong performer in high dimensional settings, but requires careful parameters, tuning, and is less scalable for large datasets. For decision trees are great for explaining results to non-technical stakeholders, but tend to overfit unless pruned properly. Lastly, random forest stand out with its balance of accuracy and robustness, thanks to its ensemble nature through its sacrifice some interpretability and its heavier computational. For this comparison, we see that random forest offers the most practical benefits for churn prediction, especially when we prioritize performance and reliability.
Assalamualaikum, my name is Nur Anis Alia, and right now I want to show how we select the best algorithm for our model. First, I clean the data by removing unnecessary columns like customer ID and convert string numbers to numeric. I also handle missing values, encoding categorical variables data using one-hot encoding and scaling the features to prepare it for modeling. Then, I use random forest to perform feature selection. This helps reduce the number of features and focus on the most important ones. After that, I train 3 different models, which is random forest, support vector machine, SVM, and decision tree. This all using only the selected features. I evaluated their performance using accuracy, classification reports, and coefficient metrics. As you can see, this is the top 10 important features before selection. Total charges is the top 1 important. Next, this is classification report of random forest result. From this, it got accuracy of 0.788 for SVM, it got 0.785, and decision tree, the accuracy is 0.724, and this is the model accuracy comparison graph. Based on the results, random forest gave the best accuracy by achieving accuracy of 0.079, then followed by SVM.
So here, the 3 algorithms that I selected, which are support vector machine, SVM, a powerful model that find the best hyperplane to separate classes, especially good for high-dimensional data. Second, decision tree, simple interpretable model that split data based on feature values. And lastly, random forest, an assembly method that builds multiple decision trees and average their result to improve accuracy and reduce overfitting. This technique allows us to classify customers as likely to churn or stay based on their features.
Next, I will discuss the importance of data preprocessing and feature selection. Preprocessing is a crucial step in building any effective machine learning model. In this project, preprocessing ensured the data was clean, consistent, and ready for analysis. For example, handling missing values. In the dataset, the total charges column had some missing values, especially when the TINA is 0, which usually means the customer is newly registered. These blanks can cause errors during model training and reduce the accuracy of our predictions. In this case, I choose to remove them because the number of missing rows was small and wouldn't significantly affect the data size or pattern. It is to keep data clean and avoid misleading the model. Second, scaling numerical values. Features like TINA and monthly charges are both numerical, but they have very different range. Some models, especially SVM, are so sensitive to scale, so we use standardization, which transforms these values so that they have a mean of 0 and a standard deviation of 1. This makes comparison between features fair and improves model performance. Lastly, encoding categorical variable. Many columns in the dataset are text-based, like contract, payment method, or internet service. Machine learning models can directly understand text, so we use one-hot encoding to convert these categorical variables into numerical format. This helps the model understand patterns and relationship between different contract types and churn behavior. The importance of feature selections includes improving model performance. By selecting only the most relevant features, we can increase model accuracy and reduce training time. Models like random forest, SVM, and decision tree perform better when they focus only on important inputs instead of being distracted by irrelevant or weak features. Other than that, it can remove redundancy and noise. Some features can be repetitive or not useful, which adds noise to the model. For example, having too many similar features may confuse algorithms like decision tree or SVM, leading to overfitting or unstable predictions. Feature selection helps simplify the model and makes the output more reliable. It also can focus on relevant data. Key features like contract, tenure, and monthly charges, online security, and technical support were selected because they are strongly linked to customer churn. For instance, customers with short tenure and no technical support were more likely to leave the company. By using only these relevant features, the model becomes more focused and interpretable. In short, feature selection helps us build smarter, faster, and more accurate models by reducing distractions and focusing on what truly matters. Next, I will discuss how does pre-processing and feature selection affects model accuracy, reliability, and interpretability. When the data is clean, meaning no missing values, no inconsistent formats, and well processed, the model can better identify patterns. In our case, we handled missing total charge logically, encoded categorical variables like contract into numerical form, and scaled numerical values like monthly charges. As a result, our random forest model achieved the highest accuracy compared to SVM and decision tree. This shows how important clean, well-prepared data is in helping the model detect churns and minimize prediction errors. For reliability, reliability means the model gives consistent and reasonable predictions even when customer conditions vary. Pre-processing plays a key role here. For example, different types of internet services shouldn't confuse the model. Even if two customers have different services type but similar patterns in other features like short tenure and non-technical support, the model still predicts churns logically. So, pre-processing helps reduce misclassification and increase the model trustworthiness. Lastly is interpretability. It is about how easy it is for humans, especially business users, to understand what the model is doing. For example, one of our selected features is technical support. If the model predicts that a customer is likely to churn and we see that this customer also has no technical support, a month-to-month contract and low tenure, that insights allow the company to take action like offering better support or contract incentives before the customer leaves. In short, pre-processing and feature selection are not just technical steps. They are what make the model accurate, reliable, and meaningful.
There are three adoptions that we will discuss in our assignment. The first one is visualization, where we can use dashboards or even charts to make sure that stakeholders can see more clear of the result of our model. The next one is integration with business system like CRM. User can actually see or get the result in real time. The last one is stakeholders training and education, where they will be provided some training so that they can interpret the result better and based on the churn risk or the high risk of their business. Ethical consideration. The first one is group customers fairly. We need to make sure our model selecting only relevant features so that it can avoid any bias during the result, in the result. So next, wrong predictions can cause a lot of false alarm. For example, we can falsely accuse a loyal customer and as a high risk and then give any unnecessary offers to them. We need to avoid that. And lastly, customers' privacy. Every customer's privacy, such as personal data or payment information, must be hidden or anonymous so that it cannot be used by any unwanted person. There are potential challenges that we might face. The first one is integration complexity. This occurs when we try to embed our model into CRM or any different models. The next one is model drift. So, as we know, not everyone has the same behavior. So, the customer's behavior will change over time, which makes the existing model to be less accurate as days goes by. And lastly, misinterpretation. Marketing and sales team might not trust the machine generator at first since it is computational and needed human brain to actually check if the result is accurate or not. So in conclusion, classification can provide valuable insights into customers' behavior, helping organization by visualizing, integration with business system, and stakeholders training. This will make sure that our stakeholders can trust and effectively adopt our model for improved customer retention and future business outcomes.